This revision video is for AQA M1. We're on connected particles and it's question 6 from January 2010. So let's see. We've got a small train at an amusement park which consists of an engine and two carriages connected to each other by light horizontal rods, which we can see here. The engine has mass 2,000 kilograms and each carriage has mass 500 kilograms. The train moves along a straight horizontal track. A resistance force of magnitude 400 newtons acts on the engine, and resistance forces of 300 newtons act on each carriage. The train is accelerating at 0.5 meters per second squared. So in part A, we're asked to draw a diagram to show the horizontal forces acting on carriage 2. In part B, show the magnitude of the force that the rod exerts on carriage 2 is 550 newtons. And then in part C, find the magnitude of the force that the rod attached to the engine exerts on carriage 1. And in part D, we're told that a forward force, driving force of magnitude P newtons acts on the engine, and we're asked to find P. So we've got a question which is worth 9 marks. So let's just start by looking at the first couple of parts to see how we go. And the first thing really is just let's consider a diagram for the whole thing and make sure we've got everything sorted. If we call this carriage 2 and this carriage 1 and this the engine, so we've got a force which is pulling the engine forward, which they called P. You've got resistance forces, so resistance forces of 300 newtons on each of the carriages and 400 newtons on the engine. And then we've also got these rods. So if we call, so there'll be a tension here, if we call that T1, and there'll be another tension here which we could call T2. It really doesn't matter, but they are going to be different. So we need to call them something different. So that's basically the horizontal forces. I'm not concerned with the vertical forces. And we're also told that it's moving in this direction with an acceleration of 0.5 meters per second squared. So that's the situation I think that we've got. So in part A it said, draw a diagram to show the horizontal forces acting on carriage 2. So if we have carriage 2 here, then basically I have a force this way which I've called T1, and we've got this resistance force of 300. So that's all we need to do in part 1. It's only carriage 2. And in part B it says show that the magnitude of the force that the rod exerts on carriage 2 is 550 newtons. So that's this T1 force. That's the force in the rod which is exerted on this carriage. So we know the acceleration. We know that using Newton's second law that the resultant force is going to cause this acceleration, and the resultant force is going to be T1 minus the resistance 300, which will be equal to the mass, which is 500, remember, for the carriage, times the acceleration, which is 0.5. So a half of 500, 250, plus this 300, so this tension is going to be 550 newtons. So that's A and B. If we move on to part C, now again I'm just going to fill this diagram in because it is quite important that we have this. So we'll just remind ourselves the mass of these were, this was carriage 2, carriages the mass was 500 and the engine had mass 2,000. Just about fit that in. We have this pulling force, P, driving force, on the engine, and we had, these were T2s, We call that T2. And here we had T1, which we have found out now is 550. So remember, we actually know that. And then we had resistance acting on the carriages of 300 and on the engine itself of 400. So again, that's just recapping because we need that information now, because this time we're going to be asked to find the magnitude of the force that the rod exerts to the engine, rod attached to the engine exerts on carriage 1. So this, if you remember, was carriage 2, and this was carriage 1, and this was our engine. Okay, so what we're actually trying to find this time is T2. So T2 will be equal to, well, it's going to have resistance forces, but so there's a minus 300 here acting on the carriage 1, but there's also this total force of that exerted, that we've just found that carriage 2 is going to exert, which is 550. So we've got the T2 pulling it forward, and we've got the 300 acting against it, and we've got this T1 acting against it, and that is going to be equal to the mass, which is 500, times the acceleration, which is 0.5. So T2, that's 250 plus 850 is going to be 850 plus 250 is going to be 1100. So 1100 newtons. And that now is the force that the rod attached to the engine exerts on carriage 1. So we've been looking at this, just at this bit. So that's part C, and then in part D, now we're concerned with the engine because we want to find the driving force P. So again, remember that the acceleration of the whole system is 0.5 meters per second squared. So now we need to find the resultant force on the engine. So the driving force P is pulling it forward, but we've now got this total force T2 pulling it backwards, if you like, opposing the motion, and that was 1100 newtons. But we've also got this resistance force of 400 newtons. And that is causing, again, we're using F equals ma here, so that is our resultant force, and the mass of the engine was 2000, and the acceleration 0.5. So if we work all that out, so that's P minus 1500 equals 1000. So the driving force must be 2500 newtons. So, as I say, there were 9 marks for that in total for that question. So if we just go back and have a little look at how the marks were allocated. So you just got 1 mark for this diagram, so that was independent of method, so a B mark. And then you got a method mark for using Newton's law and an accuracy mark there for getting 550. You got a method mark here and an accuracy mark, so a method mark for getting your resultant force and an accuracy mark for putting it equal to using F equals ma, if you like. And then we had an accuracy mark for finding 1100 newtons. And similarly here you had a method mark for here for your mass times acceleration, and an accuracy mark if you got this F equals ma all correct. So you had all the different parts of it correct, and then there was an accuracy mark for finding 2500 newtons. This was actually a follow-through mark as well, so if you did make a mistake, perhaps you didn't get 1100 newtons correct, but if you did all the other working correct, then you would have got it following through. So 9 marks in total for the question. So don't forget, there are plenty more revision videos that you can look at if you go to the Further Maths Support Programme website and follow the link to online revision.